Welcome back, everybody. This is going to be our Algebra 2 Quadratic Functions, lesson number 5, Zero Product Law Homework Review, Part 3. This one's definitely going to require a graphic calculator, so make sure you bring your calculators out here for this one. If you find the video helpful, please give a like and also leave any questions or comments in the comment section below. All right, here we go. Number 4, consider the system of equations shown below consisting of one linear and one quadratic equation. Here we have y equals 4x minus 5 and y equals 2x squared minus 5x minus 10. Find the intersection points of the system algebraically. So here it's a system of equations, and we're going to use our substitution method because they're both equal to y. And so we're going to set them both equal to y. Therefore, we have 4x minus 5 is equal to 2x squared minus 5x minus 10. And so I'm going to move everything over to the right side, mainly because I have a 2x squared already, and on the it's positive, so I want to keep that positive. I'll subtract 4x on both sides and add 5. Could you do it the other way? Yes, but factoring with a negative x squared is a little more tricky. So I want to make sure my factoring is as easy as possible. So 2x squared minus 9x minus 5 equals 0. So now I want to find two numbers that multiply to, well, here I know in this case of 2x squared, we definitely know 0 is equal to, we have here 2x next. So use that kind of like guess and check method here. Now, the two numbers I know multiply to 5 are 5 and 1. But where I put them is going to matter because I want to make sure that when I do my distribution, that the middle terms will end up subtracting to 9. Okay? And so if I put my 5 here with the x and the 1 with the 2x, we'll get, in this case, 2x times 5 is 10x, 1 times x is 1x, 10x minus 1x is the 9x we're looking for. Now, to get the signs correct, I would need a negative 9x, so I need negative 10 and a positive 1. Now, of course, we want to multiply to make sure we factor properly. In this case, let's do what you guys can check. 2x times 2x is 2x squared, so 0 equals 2x squared. 2x times negative 5 is negative 10x. 1 times x is positive 1x, negative 10x plus 1x, and then minus 5 because 1 times negative 5. And so we get 0 is equal to 2x squared minus 9x minus 5. And that's exactly the same equation we got. So I'm going to rewrite my factors here because here's we have 2x minus 1, 2x plus 1 is equal to 2x plus 1 times x minus 5 equals 0. I can move the 0 to the right side. It's that symmetric law of symmetry that if, that's basically equality is equal whether, flipped over left and right. So, and we set each of these equal to 0. We have 2x plus 1 is equal to 0. X minus 5 equals 0. Right, and we'll draw a little line between them because what happens is we're going to find the matching y values afterwards, okay? And subtract 1 on both sides, we get 2x equals negative 1. Divide both sides by 2, x equals negative 1/2. Add 5 on both sides, x is equal to 5. Now, here's the thing, we gotta find the matching y values. So we can use either the equations y equals 4x minus 5 or y equals 2x squared minus 5x minus 10. I'm gonna use y equals 4x minus 5 because it's a much easier equation to work with. So y is equal to 4 times negative 1/2 minus 5. And y is equal to 4 times negative 1/2 is negative 2 minus 5. That means y is equal to negative 7. And I use again the same equation. Y equals 4 times 5 minus 5. Y is equal to, it looks like 20 minus 5. Y equals 15. Okay, so the two coordinates we're looking at are going to be negative 1/2, comma negative 7, and 5 comma 15. All right. Now, the second part of this is where we are asked to do the following. Using using a calculator, sketch a graph of this system to the right. Meaning, we're going to sketch this now. This is going to be a little bit tricky because I may not be able to hit 15 here, and the range I have may not work out so great. So bear with me. All right. But on the calculator, we'll see. All right. Be sure to label the curves and the intersections in the window. Might be able to lower the x-axis a little bit. So let me just ungroup this here. Group, ungroup. Okay, and so now if I pull this down a little bit here, this might work out, although I might have a problem with the -7, but at least it'll be a little easier to see. Okay, now our calculator though. So let's pull a calculator up, okay? And you want to type in y equals 4x minus 5 for y1, and y equals 2x squared minus 5x minus 10 for y2. I've already set this up here, all right? And so we're going to graph, and now hit zoom 6 for a standard window. And we'll notice that some of this kind of doesn't seem to fit very well, okay? This is what it's going to look like a little bit here, all right? We do see that this graph, it kind of looks like it meets here and comes up somewhere up here. So we might have to change the window a little bit, okay? So let's add a window to our y value, our maximum. Let's make a y max. How about we make it about 20, all right? So type in 20 here. And now graph. All right. Now we don't seem to get the whole graph here because the bottom part does come up a little bit lower, so the vertex wise, but we do have a point intersection here. Okay. And so if we were to graph this, and I'm going to sketch the graph here, but I definitely know the 2 points here. I think we have a root somewhere over here. So, all right, let's take a look. Okay. So we definitely have a point of intersection at, we said in this case, I believe we had coordinates of -1/2, comma -7. So, okay, there you go. All right, -1/2, comma -7. So -1/2, comma -7 is going to be somewhere over here. That's our point intersection now, okay? And then we had 5, comma 15. 5, that's 5, 10, 15. These are 2 points we know for sure are the points intersection. Now 4x minus 5, it kind of looks like this here. Here's y-intercept of 5, going up by 4 every single time. And we know we're going to be hitting this point here. So for drawing a line, it's not so bad in this case. You see here, let's see now, I can draw a line here. Hopefully it'll fit. Okay, so this point on, and I can extend it backwards here. The parabola is going to be a little tricky though, so just to let you know. Again, I'm not going to be able to get the whole parabola in here. So it's a sketch. Now, the line was not hard to do because I followed the rules we have for lines. All right, but a parabola is going to look a little bit weird. Okay, honestly, it's going to, I think in this case, let me see, maybe I'll do some red here and looks like this. Here's a sketch, and that's what it looks like, kind of. All right, now we want to show in this case, it's a sketch, all right, so not perfect, mind you. So be sure to label the curves and the intersection points. Okay, so here, this is the curve. So this is y is equal to 2x squared minus 5x minus 10, and we have this graph here is y equals 4x minus 5. All right, and our points of intersection here, this point here is -1/2, comma, I believe we said -1/2, -7, I think it was. And this point here was, I believe, 5, comma 15. Okay? Now, what we're going to do on our graphing calculator is to use an intersect function to find the values in this case. To verify, we have negative 1/2, comma 7, and negative 5, comma 15. So let's pull up the calculator again. All right. And so here, because the intersection points are in the window, so we can see them, hit second trace or second calc, choice 5 for intersect. Now we're going to move the cursor closer to the point intersection and now hit enter once, twice, 3 times. And we see here a point intersection is going to be at negative 0.5, comma negative 7. And that's what we got when we solved algebraically. We're going to do this again. Second calc, intersect, choice 5. But this time we're going to move further up to the other point. So we found negative 1/2, comma negative 7 was the first answer. And so it was sort of close to here. It looks like 515 on right on the dot, but let's hit hit enter once, twice, 3 times, and it is 5, comma 15. So we verify on our graphing calculator that these are the 2 points that we definitely found, and they're correct algebraically. Something about graphing, sometimes the sketches are not that great. No, graphing calculator really does help though, ladies and gentlemen. Okay, everyone? All right, so yes, verified, we definitely got, in this case, negative 0.5, comma negative 7, and 5, comma 15. And that was a check on the calculator. Okay, and this will be the end of our Algebra 2 quadratic functions, lesson number 5, zero product law home review part 3. I hope it's helpful. And again, using the graphing calculator and solving system equations algebraically, we just, again, set them both equal to each other, solve for x, and then you must solve for y. We're able to check with the graphing calculator, but we would normally plug both x and y into both equations. So you really have, you're really going to be doing 4 checks because there's 2 coordinates and 2 equations each. All right. Thanks so much for watching, everybody. I will see you in the next video. Take care and be safe.